First thing we're going to talk about today is the commutative law of addition, or commutative property of addition. And really, it sounds difficult, but it's not. And all it means for you, that if you're adding a bunch of numbers, it doesn't matter what order you add those numbers in. And you could take, obviously I'm going to use smaller numbers than we're using here, but you can take 8 plus 7 plus 5 plus 6 is the same as 5 plus 7 plus 6 plus 8. Okay, the value is the same. The numbers stay the same. The order, when you're just adding them together, the order in which you add them doesn't matter. It doesn't affect the answer. If we add 8 plus 7 plus 5 plus 6, it's going to give us 26. And if we add 5 plus 7 plus 6 plus 8, it's also going to give us 26. So again, commutative property of addition just means that when you're adding numbers, only when you're adding, but when you're adding a bunch of numbers together, the order in which you add them together does not matter. For 3, 4, and 5, we're working on the associative property, and the associative property of addition literally means that you can associate the numbers in a problem in different ways. And what I mean by that is, if you were to take, for example, 17 plus 6 plus 3, you can see that the parentheses, we know order of operations, so the parentheses mean we add the 17 plus 6 first, and then we add the 3. And when we do the associative property, it just means that you could group this in different ways. We know that 17 plus 6 is equal to 23 plus is equal to 26. Now, if we were to associate the numbers like we did here in a different way, okay, we're going to get rid of this, and we could associate the numbers in a different way. It could be 17 plus the quantity 6 plus 3. Well, we know 6 plus 3 is equal to 9, and 17 plus 9 is equal to 26. So with the associative property of addition, you can associate the numbers, meaning you can change the order of operations in an addition problem, and you're still going to get the same result. Our next piece here talks about a distributive property. You will also hear it referred to as the distributive property over addition. We can take an equation such as 6 times 4 plus 6 times 9. And what they mean by distributive, okay, is we're taking a factor and we're distributing it across the problem, and we are multiplying it separately to each number. So writing it with distributive property is 6 times the quantity 4 plus 9, and this is distributive property because you are going to then multiply, you're going to distribute that 6 times 4 and 6 times 9. And if you do it that way, we know 6 times 4 is 24, plus 6 times 9 is 54, and 24 plus 54 is equal to 78. If you were to evaluate this same expression without the distributive property, and that was pulling the 6 out, and just evaluate the expression as is, you're still going to get the same answer. 6 times 4 is equal to 24, and plus 6 times 9, which is equal to 54, and that is equal to 78. And so your answer is still the same. So distributive property is taking out the factor, or adding in a factor that is distributed across the whole equation. And in this case, it's 6 times the quantity 4 plus 9. Again, then what you're doing is distributing that 6, multiplying it across to the 4, and multiplying it across to the 9. So if we look at our homework today, numbers 1 and 2 say, use what you know about the commutative property to solve for n. Okay, on one side of the equation here, we have 26,184 plus 1,546. And it's equal to 1,546 plus n. Well, how could we solve for n? Well, if we look at this equation here, we know that 26,184 plus 1,546 is equal to 1,546 plus n. Okay, so what we need to do is figure out what's missing. Well, we know that you can add those two numbers together in any order, and it's going to be the same number. So n is going to be equal to 26,184. We can move down to numbers 3 through 5, and it says regroup the numbers using the associative property and then add. Well, remember, this means that when you're grouping numbers together and you're just using just addition, it doesn't matter what order, which numbers you group together, right? You can group any of these numbers together and still come up with the same answer. So you have 7/10 plus 3/4 plus 1/4 is equal to, and what it's telling you is you can add it in a different way. You could, using the associative property, change the numbers that you're grouping together. And something that might make good sense in this is grouping together the two numbers that have a common denominator. Here it could be 7/10 plus the quantity 3/4 plus 1/4. And then solving becomes quite easy too, because we know that 3/4 plus 1/4 is equal to 1 whole. And 7/10 plus 1 whole equals 1 7/10. You can go ahead and write it on the line. Make sure you write the equation that you changed it to, meaning which numbers did you group together. And you can do that for numbers 4 and 5 as well. When you look at number 4, you might want to make your problem a little easier, and that would be something where you might want to group together the 1 200ths and 9800ths, because that's going to bring you to a whole number of 2. So look at and evaluate, and especially when you're doing fractions, if you can, combine common denominators. And when you're grouping decimals, if one of them gets you to a whole number or a number that's easier for you to work with, group those numbers together before you solve. When you look at number 6 and it says use the distributive property to rewrite the problem so it has only 2 factors and then solve, well, when you're using the distributive property, what number is being distributed here? What needs to be distributed? Well, you can see that it's the 9. So you're going to have 9, and you're going to be multiplying that by, okay, it would be 75 or 25 plus 75. However, it asks you to bring this problem down to 2 factors. So you're going to have to solve what's in the inside, right? What's in the parentheses first, and bring your equation down to 2 factors. So it's now going to be 75 plus 25 is equal to 100, and 9 times 100 is equal to 900. So you can write those equations on the line. And when you get to 7 through 10, it says group the numbers that make the addition easier and then add. And this is just a situation where you are adding numbers that make it easier, combining numbers that make it easier to add a long addition equation. And one of the things that you can do is look at the numbers first. So you're checking out your entire problem. So if we look at number 7, you can see that we have 20,000 plus 70,000 plus 30,000 plus 68,000 plus 80,000. Well, if you are going to group the numbers in ways that make it easier for you to add these together, if you added your 20,000 to your 80,000, well, that gives you 100,000. If you were then to look and add your 70,000 plus your 30,000, that gives you another 100,000. Easy number to work with, right? And then what you're left with is 68,000. Okay, so you're left with 68,000. And then all you have to do is add them up, and really then you just have 268,000. And so when it asks you to group, okay, you're grouping numbers together that make it easier. When you're grouping decimals, try to get decimals together that are going to make a whole number for you. So if you looked at these decimals, you could see that 10 and 75/100ths plus 10 and 25/100ths, okay, 75/100ths and 25/100ths are going to give you 1. So you're going to have 21 when you group those together. So look at the numbers before you decide what you're going to combine, and then combine numbers to make the addition easier for you. Same thing with fractions. Combine numbers that have common denominators before you add, and that makes your addition much more simple. You can continue and work through numbers 2, 4, 5, 8, 9, and 10 on your own, and when you've finished, please take a picture, attach it to your work, and turn it in on Teams. Thank you.